Okay, right now I'm going to run you through an example that really covers all that you need to know in Chapter 9. And so this is a comparison of two population means, a large and an independent sample. And so the scenario is this. This is one I came up with. But so you have two companies, EMC and you have Dell. This was before the merger, okay? And we're comparing the life of a standard 2 terabyte EMC hard drive to the life of a standard 2 terabyte Dell hard drive, given the following information. So basically, that 2 terabyte Dell hard drive, we're going to take 152 samples. That's our sample size. The mean of those samples, the years, would be 15.3 years, and the standard deviation is 1.2. Okay. In this example here, we have the EMC 2 terabyte hard drive. And we're going to take 130 samples of those hard drives. And when we take a look at it, basically it says that, that their average life is 18.4 years, and it has the standard deviation is 1.5. So the first thing we need to do is construct a point estimate and at a 95% confidence interval for the mean from sample 1 minus the mean in sample 2, right? And so in order to do that, what we're going to go in, it doesn't really matter, we could call this sample 1 and this sample 2, we just want to keep it consistent throughout the problem. So when we do that, we take that 18.4, we subtract from it that 15.3, and our point estimate is going to be 3.1. Now, as we move down here for the remainder of this problem, remember we're constructing a 95% confidence interval. And if we're constructing a 95% confidence interval here, we need to understand what alpha is. So alpha is going to be 1 minus 0.95, which gets us 0.05. And we can figure out what alpha divided by 2 is. So that's going to be z sub 0.025. And now if we were to go to our z table, which I'm not going to do right now, but you guys all have the ability to do this, the value that we should come up with here is going to be 1.96, okay? So now once I have that value, I can now plug it into our formula that we just covered in our last slide presentation, all right? So we're going to apply this for the confidence interval, and we have that 3.1, which is our point estimate. We pop in here. We have that 1.9, which we calculated from that z-score, which is right point here from that table. All right, now we're just plugging in what we know for the formula, right? So standard deviation from example 1 divided by the sample size, square that standard deviation. Don't forget to do that, all right? Square the standard deviation, sample 2 divided by that sample size, okay? And when we do that, we get a confidence interval of 3.1 plus or minus 0.208, or from 2.892 to 3.308. So basically what this is telling us is that with 95% confidence, we can say that we're going to fall right in between these two values. And what I mean by that is that's going to be, the difference between those two hard drives, whether it be Dell EMC or the difference not in the hard drives, but the difference in the mean years for each of those different companies' hard drives. Okay, and that's why I put this down here. It's important that you can explain the importance of your result and that you prove the understanding of your work. Okay, so now this is the second part, which relates directly to this. So essentially, what we're now doing is we're now going to do a hypothesis test on what we just figured out. And we want to figure out if we can actually accept or reject the hypothesis. So the first step, the given, is the null hypothesis, is that these two means, the Dell EMC and the Dell one and the EMC one, or vice versa, happen to be very close to each other, so close that they're virtually equal to each other. That's our null hypothesis. And then the alternative hypothesis here is saying that no, their difference is going to be so great, it's definitely going to be greater than 0. Okay, so that value is going to be greater than 0. Remember, we're evaluating it at a 95% significance here, so that's where alpha is 0.05. And you might ask, well, what does this mean? Well, basically, if they are equal to one another, then if you were to subtract them, you would get 0. That's all that means. So now step 2, we need to go ahead and calculate our z-score. So this is the formula we are using for our z-score. we're going to plug in all of our values, and what we get here is that z equals 18.3318. Okay? So now at step 4, since the alternative hypothesis is greater, then we can say that we are using a right-tailed test. Okay? And then we can also say that the single critical value right here, would, which we figured out on the previous page, was going to be 1.645. And essentially 1.645, that's going to be the interval, because 1.645 off to positive infinity. Now, what we need to figure out here is that where does this value fall? And if this value does in fact fall within the rejection region, we call it, then we can say that we reject the null hypothesis and therefore accept the alternative hypothesis here. So since it falls within the rejection region, we can say that we reject the null hypothesis since C falls in the rejection region. Okay? So essentially at the end of the day, what we are saying here is that, you know, they are not significantly close in value. We're rejecting this null hypothesis and saying that the difference between those is so much greater, and therefore there's one that is significantly better than the other.